Welcome to LearnFast tutorial. In this class, we are going to be looking into domain and range of functions. But with this particular problem we have f of x will be equal to x squared over root x squared minus 4. Now, when you are asked to look for domain and range of a function, there are rules that you need to apply. But for this particular problem, those rules you need to apply are also dependent on the type of problem you have. For this particular problem, because of these roots we have here, for this function to be defined, everything we have under this root must be greater than 0. So everything we have under this root must be greater than 0 for this function to be defined. So because of that, we are going to equate x squared minus 4 to be what? Greater than 0. Now, you also need to look out for the problem you have. If you actually have something that is actually factorizable, you also need to look out for that. And in this particular question, we have x squared minus 4. We know that we can actually factorize this x squared minus 4, which will give us x minus 2 and x plus 2. Because if you multiply these two factors, you will still obtain what we have here. Now, we can go ahead to make x stand alone, or better still, get the turning point of this function, which will give us x will be equal to 2. X can also be equal to negative 2 from these factors, right? If we equate to 0, x will be equal to 2, x will be equal to negative 2. Now, I want you to know that this can also be called the turning point. But then, we were asked to get the domain and the range of values that would define this function. Now, we should have in mind that whatever set of value we are going to obtain should be something that should be greater than 0. All right, which is, we are looking for a positive real number. Now, we are going to take these two factors and create what we call a truth table. That truth table will enable us, it will give us the correct range of values that will satisfy this function. So I'm going to create my truth table. And then I'm going to put in my factors. And also put in the product of these two factors. Now, I'm going to assume the set of or range of values so that we'll be able to test the actual range of value that will satisfy this function. From this turning point, I'm going to assume some set of values so that we can be able to test and see the one that will actually define our function. Now, we know from these two values here that this is the smallest of both of them, right? Now, we're going to assume a value for x from negative infinity, a value that will be less than minus 2, right? So we're going to be looking for a value that will be less than the smallest value of our turning point. And so we'll have that when x will be less than negative 2. Now, we're also going to look for some values or a set of value that will be within negative 2 and plus 2. And so we have when that will be within just exactly less than negative 2. Exactly less than negative 2. And when x is also less than 2. When x is less than 2. And we're also going to test for a set of values when x will be greater than 2. So we'll have x greater than 2. Now, from this table, we can substitute any number that is less than 2 for x to see if we got if we obtain a negative sign or a positive sign. And if we substitute negative 3, because negative 3 is less than negative 2, if we substitute negative 3 for x, we will obtain a negative sign, because minus 3 minus 2 will give us a negative sign, or minus 5 rather. So we're actually interested in the signs and not the numbers or the values. So if we repeat the same thing here, we have negative 3 plus 2, which will give us what? A negative sign. Now we are going to test for set of values, set of numbers that is just exactly less than 2, but not exactly up to 2, right? Which is less than negative 2, but not exactly up to 2, right? So let's take the nearest whole number, negative 1. If we substitute negative 1 for x right here, we still obtain a negative sign, because negative 1, negative 2 will give us negative 3. And then if we substitute a negative 1 also into, we'll substitute a negative 1 for x, we'll have a positive sign, because negative 1 plus 2 will give us positive 1. Then when we substitute a number greater than 2, let's say 2.1345, we obtain a positive sign, right? And we also do that for this, we also obtain a positive sign. Now we are going to multiply these two signs to give us the product. So when negative goes into negative in multiplication, the product will give us a positive sign. Negative and positive will give us negative sign, then 2 positive gives us positive sign. Now you can see that the set of numbers that will, or the set of values that will define this function based on this rule will be all numbers less than negative 2, all numbers from negative infinity but not up to negative 2, and all numbers from all numbers that are just exactly greater or greater than 2 but not exactly 2. They are greater than 2 then to positive infinity. So the solution to this problem is x is such that x is less than negative 2, which is exactly what we have here, union, this means, and x is also greater than 2. So these are the solution to this problem. This is the exact solution to this problem that we have. So we have that solution to this problem will be equal to this. Now, for us to write the domain of this function, we have that the domain of this function is from negative infinity, from this up to negative 2, but not including negative 2, and 2, not including 2, down to what? Positive infinity. So this is the domain of this function, and of course the range of this function is all positive real number. Thank you for watching. Please make sure you share this video to your friends, follow our page, like this video and subscribe to our channel. See you on our next class. Bye.